What's up everyone, Patrick here, welcome back. Moving on to the next video dealing with quadrilaterals. So we are given a quadrilateral that has the vertices capital A and the coordinate is small a, small b. Then we have the vertice capital B and then the coordinate is CD. Then we have C, E, F and then D, which is the coordinate G, H. So notice we're not dealing with any numbers here. These are all going to be in terms of variables. And what we have to do, we have to find the midpoints of each side. And then in part B, we have to show the lines joining the midpoints form a parallelogram. So in the previous video, we verified this property with actual numbers. We just made a random quadrilateral on the fly. And now we're going to really generalize it and not even use numbers, but just use letters to represent the coordinates. So let's first start off with a diagram. So if I just draw any quadrilateral, so we'll call this A, let's say B is like here, let's say C is there, and then let's say D is maybe like over here. Like that. Okay, and let's label these. So A, B, then we got B, which is C, D. Then we got C, which is going to be E, F. And then we have vertex D, which is going to be G, H, like that. So in part A, what we're going to do is we're going to find the midpoint of each side. So let's start off with the midpoint of side AB. Midpoint formula, just as a review, it's the average of the x values, the average of the y values. So I'm going to label this x1, y1, and then I'll label this x2, y2. So what we're finding is this that midpoint over there. So we'll have x1, which is A, plus x2, which is C. That's going to be divided by 2. And then we'll have y1 plus y2, so we'll have B plus D. And then that's going to be divided by 2. Okay, and then this over here, you can't simplify any further. There's no like terms in both of those. So this point here, it has the coordinate A plus C over 2. And then B plus D over 2 like that. Now let's find this midpoint. So we have x2, y2 for B. Let's label C as x1, y1. So we're going to be finding the midpoint for BC now, which is just going to be x1 plus x2. And actually, you know what? I'm going to go in alphabetical order. So instead of doing E plus C, I'm going to do C plus E. It doesn't matter which way you do it. I'm just going to keep it in alphabetical order. So we'll have C plus E divided by 2, and then we'll have D plus F divided by 2. Right? So that's going to be this midpoint over here. So we'll have C plus E over 2, then we'll have D plus F over 2 like that. Okay, and if we just follow the same procedure, so now we're going to find this midpoint. It's going to be the average of the two x values, so it's going to be E plus G over 2, and then the average of the y values, which is going to be F plus H over 2 like that. And then this midpoint over here, the average of these two x values, so it will be A plus G over 2, and then B plus H over 2, like that. Right, so those are all the midpoints. And now what we got to do is we got to verify, remember the property, if we join the midpoints of any parallelogram, that's always going to form, or sorry, join the midpoints of any quadrilateral, that's always going to form a parallelogram, right? So how do we verify that something's a parallelogram? Well, it has two pairs of parallel sides, like that. Okay, so we're going to have to find the slope of each side and make sure that this side and this side are parallel, then this side and this side are parallel. So what I'm actually going to do is I'm going to erase these other points here. We're actually not going to need them anymore, just to have a little bit less going on the board here. right? So we're just looking at this quadrilateral now. That's formed by the midpoints, and as we know, that's always going to form a parallelogram. It's just we have to verify it now. So what we can do is let's actually label these. So we can label these let's label them E, capital F, capital G, capital H. Right? The other one was labeled up to capital D, so we'll start with E, F, G, H, just to follow along with what we're doing. So for example, I'm first going to find the slope of EF. Okay, the slope between these 2 points here. Now the slope formula, rise y2 minus y1 over x2 minus x1, like that. So what I'm going to do is I'll let E here be x1, y1, and then I'll let F be x2, y2. Again, it doesn't matter which one you label which, you're still going to end up with the same thing. So notice that y2, we got b plus d over 2, minus y1, which is b plus h, that's going to be over 2, and then that's going to be divided by x2 minus x1, like that. So what we can do here is let's work with the numerator separately, just because there's a lot going on there. Right, there's a lot of fractions. So notice we already have a common denominator. So what we can do is we could take this and subtract that. Now, because we're subtracting that whole thing, what you got to do is you got to make sure that you put that in brackets. Then you could put that all over 2. Right, so if this was like 7 over 2 minus 3 over 2, we could rewrite this as 7 minus 3 over 2. That's what I'm doing here. I'm just putting it as one fraction because you're subtracting that whole thing. Right? This is like a whole expression. You got to put a bracket there. Right? That's key, because what's going to happen is now you got to distribute the negatives, so you'll have b plus d minus b minus h. That's going to be over 2. Notice the b's cancel out, so we're left with d minus h over 2. Okay, so this whole numerator here in brackets simplifies to d minus h over 2, like that. Okay, and then if we do the exact same thing with the denominator, combine them into one fraction, notice a plus c minus a plus g, that's going to be over 2. Distribute the negative inside, so the a's would cancel out because we'd have a plus c minus a minus g, so we'd be left with a c minus g over 2. So this would be c minus g, that's going to be over 2. So notice we're taking one fraction, dividing it by another. So what we can do is we can rewrite this as d minus h over 2 divided by c minus g over 2, and then we flip this fraction. So we'd have d minus h over 2 times 2 over c minus g. The 2's cancel out. Multiply both of these, we end up with d minus h over c minus g, like that. Right, so lots of algebra here. But nevertheless, the slope, let's keep track of it over here, of EF is equal to d minus h over c minus g, like that. One thing I want to mention here, this and this are the same thing. Okay, we can rotate this and then rotate that. Both of these here are the same thing. And the reason why I want to mention it is because depending on how you label this x1, y1, x2, y2, for example, when we're going to find the slope of GH, you might end up with this over here, and you might think this and this are different when you look at them, but they're actually the same thing, because what we can do to get to here is we can multiply this by -1 over -1, like that. So it's like we're multiplying this whole thing by 1, right? -1 over -1 is just +1, and then 1 times anything is just that same thing, right? So what we're doing is we're just changing the format here, and then -1, you would distribute it to both of these. So you'd end up with -d and then plus h, right? Plus h minus d, and then the -1 here, the positive c would turn into a negative, the negative g would turn into a positive. Another thing you could do here is you could factor out a -1. Now, at this point, you may or may have not dealt with factoring in the course, so that's why I wanted to show you this first. But if you have dealt with factoring, well, you could just take out a negative from this, and it would turn into h minus d, or -d plus h, which is the same as this. Then we could take out a negative from here, and it would turn into g minus c, or -c plus g, which is the same as this, and then the negatives here cancel out, and we end up with that. Okay, but if you haven't dealt with factoring yet in the course, then this is the method where you could show that this and this are the same. Okay, so just want to point that out, that for all of these, if you have something like this, you could rotate this and rotate that. Both of them have to be rotated, so this and this swap places, then this and this have to swap places. And then both of them are the same thing, just in case you get a different format when you're doing the algebra yourself. Okay, so now let's move on to finding the slope of FG. Okay, so this is x2, y2, I'll label this as x1, y1. Okay, so what would we have? We'd have y2, which is b plus d over 2, minus y1, which is d plus f, and then that's going to be over 2. Then we'll have x2, which is a plus c, that's going to be over 2, minus x1, which is c plus e, and then that's going to be over 2, like that. Okay, now this here, let's just actually, just because we worked with the fractions in the previous one, so we should be pretty comfortable just doing it all in one step at this point. So we'll have a plus c minus c plus e, right? And then that's going to be all over 2, like that. Then we would distribute the negative here, so we'd end up, the next line, this would be minus d minus f. Then distribute the negative, so we'd end up with minus c minus e. Notice the c's cancel out, the d's cancel out, so we'd end up with b minus f over 2 divided by a minus e over 2. Okay, so we're taking a fraction, dividing it by another fraction, which is like taking that first fraction, multiplying it by the reciprocal of that other fraction. 2's cancel out, and we end up with b minus f over a minus e, like that. Okay, so that ends up being the slope of FG. So we have b minus f over a minus e, like that. Okay, now let's move on to the next one. So we'll find the slope of GH. So we got x1, y1 there. Let's label this as x2, y2. So we'd end up with y2, which is f plus h over 2, minus y1, which is d plus f over 2, all over x2, which is e plus g over 2, minus c plus e over 2, like that. Okay, and following the same thing, we take the negative, distribute it to both of those, so it'd be like that, all over, same thing here, distribute the negative to both of those expressions in that second numerator, like that. And the f's cancel out, the e's cancel out, right? This kind of looks like a c, so I got a little confused there. Yeah, so the e's cancel out. Okay, and so we're left with h minus d over 2 divided by g minus c over 2, which would be h minus d over 2 times 2 over g minus c. The 2's cancel out, so we'd end up with h minus d over g minus c, like that, for the slope of GH. Okay, and notice that, see, this and this, they're in a different format, as I mentioned before, but they are the same thing. So what we could do is we could take this, multiply it by -1 over -1, and then all of the signs change. So we'd end up with d minus h over c minus g, which would be the exact same thing as that, right? So this and that, they are the exact same thing, right? So that's an example of where, depending on how we labeled the x2, y2, if we labeled this as x2, y2, and then this as x1, y1, then we would have got this format right away. But because we labeled it differently, we got a different format, but nevertheless, as I showed before, it still is the same thing. Okay, so what we can do is label the slope of GH as this, d minus h over c minus g, and that's expected, right? The slope of EF should be the same as the slope of GH. Both of these slopes are the same. And now finally, let's find the slope of EH. And we already have it labeled x2, y2, the h coordinate, x1, y1 for the e coordinate. So we'll have f plus h over 2 minus b plus h over 2 all over e plus g over 2 minus a plus g over 2. So this would end up being f plus h minus b minus h, right? After we distribute that negative inside that bracket, that's going to be all over 2, and then we'll have e plus g minus a minus g like that. After we take that negative, distribute into that bracket, that's still going to be all over 2. The h's cancel out, g's cancel out. So we'd end up with f minus b over 2 here for this fraction, divided by that fraction right there. So we're going to be dividing by, keep getting mixed up, that's an e, right? Yeah. Kind of looks like a C sometimes. So E minus A over 2, right? Yes, the E right there. Okay, so now we'll have F minus B over 2 times 2 over E minus A. The 2's cancel out. And we end up with F minus B over E minus A for the slope of EH. Notice, different format than that, but it is the same thing. To show how we could take this to that, we could just take this, divide it, or multiply it by -1 over -1, right? Which is like multiplying it by 1, keeping it the same, just a different format. Okay, so if you ever get to this and you want to show to get to that, just put this over here. And then in your next line, you could show b minus f over a minus e. Okay, and you should get full marks for that right there. Maybe your teacher will even allow you to leave it like that and just say that both of those are the same, but they may want to see that extra step of you showing it. Okay, so the slope of EH equals b minus f over a minus e. So notice this and this, same slope, means they're parallel. This and this, same slope, which means they're parallel. So we verified that taking the midpoints, joining them for any quadrilateral does indeed form a parallelogram.